Newton's first law of motion, inertia. Do things move on its own? The cupboard moves on pushing. Now you can see a big ball over there. He is looking at the ball, waiting to see whether it can move on its own. Does it move? No, it doesn't. He is now going to try to make the ball move. See what he is doing? He is pushing the ball, right? Pushing the ball makes the ball moves the direction in which it is being pushed. For any object to move, it requires an external force. Here, that external force is what is being given in the form of push by the man. The ball moves in the direction in which it is being pushed. And now, you all will have a question. How the ball will stop? Unless and otherwise, if it is not stopped, it will keep on moving. Whichever direction it is being pushed, it keeps moving in that direction. You can watch. It is not moving in the right or left in its own accord. The direction in which is pushed, it moves. Sir Isaac Newton described this. All these things happens because of the reason called as inertia. What is inertia? Inertia is the state of rest. Any object tends to stay in the rest position. Inertia depends on the mass. It do not depend on the state of matter or the shape or size. It depends on the mass. Man is easily able to kick the stone when it is small. See, when it is big, he is unable to kick it. Then what does it mean? It means that when the mass is more force is required. See, now you can find out that he is unable to stop the ball when it is very big. More the mass, greater will be the force. Based on all these instances, Newton gave his first law of motion. Any object will continue to be in the state of rest or in uniform motion unless any external force acts on it. Newton's second law of motion. We have learned from the first law, unless and otherwise, if any object is not pushed or pulled, it does not change its position. Is it not? Now let us take the interesting example of rockets. You all know, and you could see also here, the velocity of the rocket keeps on increasing. You can very well see that the speed of the rocket at 8 seconds is 161 km per hour, and it keeps gradually increasing. You could notice that at 60 seconds it is 1609 km per hour. At 120 seconds, which means 2 minutes, it is 4828 km per hour, which tells us that with the increase in the time, there is increase in the velocity, which means the rocket keeps on getting accelerated. What is the reason for the increase in the velocity? The continuous combustion in the engine of the rocket creates a force, and this in turn creates a force in the opposite direction, which makes the rocket to move up. Isaac Newton gave his second law of motion, stating that the force is equal to the product of mass and acceleration. Now you can see when the force is given, you can check that the acceleration increases. Right? Now what happens when the mass is reduced? Then also the acceleration increases. Can you see? Right. When the mass increases, what happens? The acceleration reduces. So this relationship was neatly given by Newton, stating that the force is equal to mass multiplied by acceleration. Remember, any object for that reason gets accelerated due to the force, and this acceleration is in the direction of the force. Newton's third law. The ball, when is hit on the floor, bounces back. It is a very typical example for the Newton's third law. See, when the ball hits on the floor, it is action. The ball bounces back from the floor. This is a reaction. This is what the third law says. For every action, there is equal and opposite reaction. Now, let's sum up all the three laws of motion. Newton's first law, inertia. Second law, F is equal to ma. And the third law, for every action, there is equal and opposite reaction.